Here's what we're looking at. The last section that I told you we still had to go over, we're just going to cover that stuff as it comes up in the study guide because I decided I would rather have more time on the study guide instead of having to rush through it. Because this one takes me a little bit longer to get through for some reason than some of the other ones. So what I figured we would do is we're going to split this thing up. It'll be uneven, but most of the front part is pretty straightforward. So we're going to get through the first page, the front page today. Then tomorrow we'll get through the back page, and we'll still be on schedule to take the test on Friday. Okay? Does everybody understand what's going on and where we are? All right. So the first two, numbers 1 and 2, that's the last thing that we've learned and that we went over. It gives us the zeros on number 1 of -2, -1, and -I. And it says to write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So the first thing we talked about when we went over this was whenever they give you an I, to get an I that came from a square root, and square root can always be positive and negative. So if you have an answer that's -I, you also have a hidden answer that's positive I. Okay, that's where they try to trick you. They don't write them both. But you got to know that an I comes from a square root, and square root can be positive or negative. So you have a hidden I that you've got to include. Now to write this, if these are your zeros, we talked about this earlier, -2 comes from x plus 2. Because if you said x plus 2 equal to 0 and solve, that would get you a -2. -1 comes from x plus 1. -I would come from x plus I. And I would come from x minus I. So essentially all you've done is taken your zeros, rewrote them as factors, which means they have the opposite sign. Then from there what we do, we're trying to write this as a polynomial function, so we're going to just multiply all that stuff. Now when we did this earlier, I think it was Monday, if I'm remembering right. When we did this Monday, I told you that, if you remember, we've not had any polynomial functions that had i's in them. So odds are these i's are going to cancel out. So that's where I'm going to start. I'm going to multiply these two with the i's together first. You don't have to. I just think it's easier to see if those i's are going to cancel out. So I'm multiplying these two here. My x times x, get me an x squared. My x and a -I gets me a -xi. My x and a I, both of them are positive, gets me a positive xi. And then my I times -I, positive times negative is a negative, and I times I is I squared. So what you see here, you got a negative and a positive, so that cancels, so that's good news. And then I got minus I squared. Well, what's I squared the same as? -1. So minus -1 is the same as, so for these two factors, we have an x squared, and we have a plus 1. So that is part of my, I don't need to lose that. So I'm putting in that dotted box there because I don't know what else to do with it.
Now you multiply your front stuff to get the rest of your equation.
Good. Now what Grant's talking about is I can multiply that x squared plus x plus 2 times x plus 1. I'm going to multiply these two, and then I'll have my, then after that I'll get another polynomial that I'll multiply by that. Right? So we still got several steps to go. Alright, so this gets me x squared. Here's a 1x. Here's a 2x. And here's a 2. So those like terms, x and 2x, is a 3x. Okay? So those two things in my dashed rectangles now, I got the trinomial. I got the trinomial for multiplying these two. I got this binomial for multiplying these two. So now I need, this is still all multiplication, so now I'm going to multiply those two answers. Okay, the binomial, I'm going to take that and distribute the x squared to all three of these. I'm going to distribute the 1, that's easy, to all three of those, and then I'll combine like terms. So let's scroll that back up and get a new color marker for, well, I don't almost scrolled, does it? Oh, scrolled way high then. Well. Alright, so x squared times x squared. Yes, ma'am, very good. X squared times 3x. 3x cubed. X squared times 2. 2x squared. Okay, everybody good so far? Now when I distribute that 1, good thing about multiplying by 1 is it doesn't change, but we still have to do it because that's going to give us some like terms to combine. So 1 times x squared will be x squared. There's your only like term you're going to get. 1 times 3x would be 3x. And then 1 times 2 would be 2. Now, recall that the directions said write a function f, so as I combine my like terms, I'm going to name this f of x is equal to x to the 4th plus 3x cubed. Here I got a 2x squared and a 1x squared, so that's a 3x squared. Got a lot of 3's in this. A 3x and then a 2. So all of that whopper is my number 1 answer. Okay. We ready for number 2? Any questions on that one? The thing to remember and to maybe circle it and write yourself a note about is we had to add the positive I. They only gave you negative I. You had to include positive I. Okay?
So if they give you positive I, you have to do the negative I?
Yes, ma'am. Very good. Very good. Alright, so on number 2, we've got 4 negative square root of 5 and negative 5. Now this one doesn't have any i's, but it still has got the same premise. It's still got a secret 0 they didn't tell us.
Is it positive?
Very good. If you get a negative square root of 5 like they did right here, when you take square root, it can be positive or negative. So they should also, and you need to include a positive square root of 5. So if there's an I, like we said on number 1, you got to have both positives and negatives. If there's a square root, you got to have both positive and negative. Okay, now when I start writing these factors, because that's our next step, I'm going to put the regular numbers by each other, and then I'm going to put the square root numbers by each other so I can multiply them together just like we did with the i's. So I'm going to have x minus 4, and then I want this negative 5, that would be x plus 5. I'm going to put those two next to each other. Okay, now to get a negative square root of 5, that would be x plus the square root of 5. And then my blue one here would be x minus the square root of 5. So I'm going to attack this the same way we did with the i's. We haven't had a polynomial function that had a square root in them, so odds are those square roots are going to cancel out. So let's multiply those two together first and see if those cancel out. So x times x is x squared. Positive and a negative right here makes a negative, and it's just an x with a square root of 5, so however you want to write it. And then in the middle, they're both positive, so it'll be a plus an x with a square root of 5. Okay, and then on my last, I got a positive times a negative. It's a negative. Now that square root of 5 times the square root of 5 is the square root of 25, which is 5. Very good. So now, just like on the i's on the previous problem, what happens with those dudes right there? They gone. Very good. So we got an x squared minus 5 that we're going to need to hold on to use in a minute.
I have a question.
You got it.
So, I'm going to have to think about how to word this.
Let me answer Garrett's question while you're thinking about it. Right here, Garrett, square root of 5 times the square root of 25. I said that wrong. I was already saying the answer. Square root of 5 times the square root of 5 is the square root of 25.
Oh.
And then we simplified that.
So So if a number in the square root, if it went squared,
Anytime you multiply a square root by itself, you're left with that number.
okay, that's what my question.
Pretty cool. I like it. Alright, so over here now, let's do the x minus 4 and x plus 5. So that'll get me an x squared. And then here's a positive 5x. And then here's a minus 4x. And then here's a minus 20. So that gets me x squared. 5x minus 4x is a positive 1x. Okay, so now I'm at that same stage that I was on number 1. I'm going to take my x squared right here and distribute it to all three of those. And then I'm going to take my negative 5 and distribute it to all three of those. Okay, so x squared times x squared is x to the 4th. Let's put another piece of tape in that, make that fatter. And then x squared times x is x cubed. X squared times negative 20 is negative 20x squared. Okay, now we're going to take the negative 5. So negative 5 times x squared. Negative 5 times x. And negative 5 times negative 20. Okie dokie. F of x equals x to the 4th plus x cubed. Negative 20x squared and negative 5x squared gives you negative 25x squared minus 5x plus a hundo. There's one that, which one is it? Number 4. I couldn't get it all on the blank. And these went off blank too at number 4. I like it. Underneath it.
Now I gotta like get more paper out. Let's just add
Now when we got to 3 through 8, the directions changed. It says find the product or the quotient. So that just tells you you're going to be multiplying or dividing. Okay? Are you ready to give those a whirl? Of course. Alright, so on 3, they got 2x minus 2 squared. It's alarming that I still see people making the mistake here and thinking they can just distribute the square to both of those. We've talked about this. We know that's not what's happening. When that whole quantity is being squared, that means you got to write it twice. If the whole quantity is being cubed, like on number 8, that means you got to write it 3 times. If you've got one that the whole quantity is to the 5th power, you got to write it 5 times. Okay, so to start this means this is 2x minus 2 times 2x minus 2. And now you go to work on your multiplication. So I had a 2x times a 2x. That got me 4x squared. A 2x times a negative 2 got me negative 4x. A negative 2 times a 2x got me another negative 4x. And then negative 2 times negative 2 got me positive 4. So combine your like terms, and that would be your answer on number 3. Would you like to know a shortcut on that? Some people don't. They think they confuse them. So if a shortcut confuses you, then just don't listen. This comes from the square of the first term. So anytime it's a the whole quantities being squared, that's a perfect square trinomial. So square the first term. This comes from what you get if you multiplied those and doubled it. So 2x times 2 is 4x, double it. And then the last term squared. No shortcut for Casey.
Right. I get lost.
Alright, number 4. Number 4 is the one that that space did not suffice for me. Because the answer's pretty long. Yeah. We got c to the 8th. And if you are working these on your own and you want to just use x's, that's fabulous. C squared minus 4c. Okay, so on this, I can't use my first, outer, inner, last because one of them's a trinomial, but it's the same thing. I'm just going to distribute the c to the 8th to everything in the trinomial, and then distribute the -6 to everything in the trinomial. Now you got to remember here, when you multiply, these powers get added. So that c to the 8th times c squared is a c to the 10th. 8 plus 2. C to the 8th times -4c would be -4c to the 9th. And then c to the 8th times -2 would be -2c to the 8th. Okay, everybody all right so far? So, not any difficult math where you would probably miss that if you were gonna, but you'd forget what to do with the exponents. So you need to remember, when you multiply, they get added. All right, now we go to our -6. And this is why I had trouble fitting this all in the blank, because there's not going to be any like terms to combine. This is just going to keep dragging out. -6 times c squared is -6c squared. -6 times -4c is a positive 24c. And then -6 times -2 is a positive 12. So all of that is your answer.
Oh, that's not hard.
No, it's not. Not hard at all.
I thought it was going to be like a lot of words.
Oh, I meant my answer. See, I couldn't fit all my answer in the blank is what I meant.
Oh.
I'm sorry, I misled
page
you.
for that.
That was misleading on my part. I'm sorry. Okay, so that was 4. Number 5. 5 and 7 are the two division problems. So just look at those with me real quick before we do 5. 5, I'm going to use synthetic division because that's an x to the first. But then on 7, that's the one that we'll have to do long division on because it's got an x squared. So just keep that in mind. And I told y'all, I promised y'all on the test I wouldn't give you more than one long division one. So you see that's the case here on the study guide. There's one long division one. All right, but 5 I'm going to set up synthetic. So I've got a 4x cubed, a 20x squared, a 12x, and a -16. And then it tells me to divide by x minus 4. So if I take that x minus 4 and set it equal to 0 and solve, that means a positive 4 would go outside my box.
Wait, how do you figure that out?
Whatever they give you as the factor, you set that equal to 0 and solve.
Okay.
Okay? Alright, so to start this, we drop our 4 all the way down. And then we multiply. 4 times 4 is 16. Put that underneath the next number and add. And then you multiply that by the 4 that's already out there. So what's 36 times 4? 144, I think. 144. Thank you for concurring, Michaela. And then I add. So that gets me 156. What is 156 times 4?
624.
624. And then I add. So I think that is 608. Okay. Now remember when we were solving these things, if we didn't get a 0 there, it meant it didn't work. But that wasn't our direction. Our direction just said to divide, so we're okay. That's your remainder. So this started off as a 4x cubed, so that means my 4 is 1 power less than that. So I write my answer here as 4x squared, using these numbers on the bottom, 36x. My constant's 156, and then my remainder over what I divided by. Go ahead, ask me.
I'm confused. Where'd you get 156? That's what I'm trying to figure out.
Did I add that wrong? 2 plus 4 is 6, 1 plus 4 is, that's right.
Never mind.
That's okay. Y'all,
But I'm confused by how you got 144.
36 times 4. Check me, I might have been
Wait,
Okay, but
why would you put x squared?
20 plus 16.
Oh, you're adding.
Yes, it's multiply, add. Yes, I'm sorry. Okay. Other questions on that? Michaela, did you get yours answered?
Why is 4 squared, not 36? So like,
Once, whatever this, the problem started off as cubed, so your first answer is one below that, and then they go in descending order. So second, first, nothing. Lane Joe, did y'all get it figured out what y'all talking about?
Yeah, well, he was confused on how you got x squared, 4x squared.
Okay, now I'm still confused.
Okay.
Okay. So you multiplied? So you multiplied?
Well, to start with, you bring the 4 on the way down, so there's nothing underneath that.
Yeah.
So 4 times 4 is 16,
Yeah.
and then you add. And then 36 times 4 is 144. And then you
I'll
add.
get a
That's
few.
what
Whatever you get when you add is your new multiplier.
Oh, okay. But like these, that's not. Push it. So 36 times 4.
Uh-huh. That's where the 144. What's the matter? Styling. No one has ever commented on my style before. Except for I have nieces, twin nieces that are fixing to turn 13, and they're the absolute most rotten people on the face of the earth, but I love them with everything I have. So their Christmas and then their birthday is December 28th. And their mom, my sister's birthday is December 27th. So it's completely exhausting Christmas time for us. But anyway, they were telling me all these things they wanted me to get them for Christmas, and it was all in their birthday, and it's all gift cards. I'm like, I'm not buying you gift cards. I gotta buy you something that means something. What are you gonna buy with the gift cards? And they said clothes. And I said, well, I'll get you clothes. And they looked at me and said, no. I was like, what's that supposed to mean? What's all
I would
about
let you
clothes?
buy.
The gift works.
Yeah.
So I'm
I
not
could
getting
rock
them
like you
clothes.
coach
You don't pass.
You didn't see? Did you not see me with my bus driving hat on this morning? Shut up. You have to get a. This is what my nieces got me for Christmas last year. Is my bus driving hat. Because they asked me what I wanted for Christmas, and I said I gotta have a good hat for driving the bus, and this is what they got me.
That's a good hat for driving
It
the
is a
bus.
good
Yeah.
hat.
Very good.
So I had it on this.
Is it warm?
Oh yeah.
There you go.
My mom does this
Yeah,
thing
go.
where, like, instead of getting us presents, she takes us to do stuff. So
That's pretty fun.
It's cool.
Yeah.
But like, so my aunt will take us out and like we go shopping.
It's cold. I don't want to get out.
Well,
I
I
mean,
mean,
just sit inside and sleep.
it's fun to sometimes I'd rather just get stuff.
All right, numero 6. If you don't like those B's, change them to X's. It works the same. I generally don't like B's because if I'm not real careful, I end up getting confused with 6's. I try to be real careful when I wrote those there, so we'll stick with it and see if I can be careful throughout. You can go in any order you want here, but what you need to know that you're doing is you're going to multiply 2 of them together and get an answer, and then multiply that answer by the third one. So that's your process on this. So I'll work left to right and do the first 2 together. Go ahead, Lainey Jo.
Okay, so I have a question. Going back to that shortcut you talked
Uh-huh.
to, couldn't that be b plus 3 squared?
It would be b squared plus 6b plus 9.
I got a
could do it
different
like that.
answer.
Yes.
Okay, I figured out how you did the thing that we were doing a second ago, but everyone else knows that.
Let me go back. Let me go back to that synthetic division. You didn't write the problem down right. That's 16. It was a negative. Okay. So I'm going to go ahead and multiply these out. That b times b gets me b squared. Lane Joe, do you see why it's a double? The 3b, you get that twice. So, I mean, that should just make that shortcut make more sense to you.
Yeah, that's because I tried it. I got the answer, but then I tried it with the shortcut, and I got the same thing.
Good, good. So then your 3b's there gets you a 6b. What are you looking at? So, did you,
Yeah, I got that.
where did you get the 6? This, remember this is at 156 plus 4. Where did you get this? I don't know what you're doing.
No, that's because you added,
Okay, my bad.
you add 144 to 4.
Yes,
And then you get 156.
okay. So this is your, okay, this is just where you did your work to show yourself.
Yeah,
Okay,
yeah.
okay. I was trying to
Write
make that.
everything
Yes,
down.
that's okay. All right, so now I got to take that answer, and I haven't used the b plus 2 up there yet. So now I got to multiply that times the b plus 2. So you can distribute it either way. I'm going to take the smaller one and distribute it. So I'm going to say b times b squared, b cubed. B times 6b is 6b squared. And b times 9 is 9b. Now I have to go with the 2.
So plus 2b
So
squared.
plus 2b squared. Good. And I'm going to stack that up with my like term. You don't have to. That's just the way I like it.
12b?
And then a 12b. And then you got a constant here with the 2 times 9. 18. So I got you, CJ. Now all I need to do is combine those like terms. So I got a b cubed, an 8b squared, a 21b, and an 18. Fabuloso.
This is making a lot more sense.
Good. Good, good, good,
Good,
good.
because I've been trying for 3 weeks.
Oh, that's all doubted there. You just pay attention when you don't have anything better to do. Here. Sorry.
What's up?
Alright, on 7, we get to do our fabulous long division.
I hate it. I don't understand it. I hate what I don't understand.
How much goes that?
Okay, I'm trying something very
About,
Because in algebra 3, and then fraction,
I know.
she's getting on our head about how I'm doing it all wrong. Why don't y'all teach it the same way?
I told you our teacher will probably even teach it another way.
Okay, well, she was yelling at me,
Yeah, we can
and I was like,
say-
well, I failed algebra 2, so I'm sitting in algebra 2 again, and I've learned it this way.
Can you say before you
Did you get the right answer?
Yes, but she doesn't care. She's learning it wrong, so I didn't do it
First
first.
I was
Yeah, that's
playing
what
Iron Man.
She's so
I had the same problem.
That's not fun.
Yeah.
Alright, on our long division,
That was
I got a 3x to the 4th. Notice you're missing something, and what we have to add when we're missing, minus a 2x cubed plus a 0x squared. Notice that, plus a 5x
Wouldn't that just be x
minus a
squared?
3. No, because if it's just x squared, that would mean 1x squared. So if you're missing one in both long and synthetic division, you've got to put that 0 in.
Wait, why is that little box thing here?
I don't care.
Why would you just...
Because it's a division problem.
That's like 3rd grade.
I've never even seen this in my life.
Well, then we've already done it in here. that goes back to that paying attention when you feel like it thing I was talking about earlier. X squared minus 3x plus
Where it
1.
has a little lip at the bottom.
Okay, so what we do on our long division, we take the first number outside and the first number inside. So that's how the whole show starts. We say x squared times what would get us 3x to the 4th. So we know it's got to have a 3 because you,
3x squared.
right? So we got our 3, and then we go from x squared to x to the 4th. Okay, isn't this correct? Had to be an x squared. Okay, so what we're going to do now is take that 3x squared and distribute it to all 3 pieces that are out here, and then that'll line up underneath. So 3x squared times x squared gets you 3x to the 4th. And remember, that was the point. You wanted the same thing. You're trying to eliminate that.
So how did you get 3x squared?
Because I did some math and figured out x squared times what makes 3x to the 4th. So it's got to have a 3 to go from x squared to 3. And then x squared to x to the 4th went up by 2, so it's got to be a 2 on the square, on the x.
Okay.
Alright, so we did 3x squared times x squared, we got 3x to the 4th. And now 3x squared times negative 3x. So 3 times negative 3 is negative 9. X squared times x is x cubed. And then I got 3x squared times 1, because we multiplied times everything out there. Now, long division subtracts. Synthetic division added, long division subtracts. So we got 3x to the 4th minus 3x to the 4th is nothing. He gone. Negative 2x cubed minus negative 9x cubed is 7x cubed. 0x squared minus 3x squared is negative 3x squared. Okay, what did I do after that?
Did you bring out
Okay, I'm going to bring something down. What am I going to bring down?
the 5x minus 3?
Just one of
Just
them.
5x.
Good. Remember, we got to have as many on the bottom as there are out in front.
So you have 3.
Got to have 3. Now, Garrett, our process is the same, but we're using the x squared with the 7x cubed. So we got to figure out x squared times what would get us a 7x cubed.
Wait, so why did you not bring down the negative 3?
Because I can only have, like I just said, I can only have as many things down here as I do out here. So if I brought down the minus 3, there would be 4. I'm going to bring it down on the next level, Garrett. You just bring down one at a time. Okay, so x squared times what gets me a 7x cubed? 7x. Now I distribute that 7x to all 3 of these things out here. So 7x times x squared is 7x cubed. 7x times negative 3x
Is plus.
negative 21x squared. And 7x times 1 is a positive 7x. Now we're going to subtract those rows. 7x cubed minus 7x cubed is nothing. He gone. Negative 3x squared minus negative 21x squared.
18x squared.
18x squared. 5x minus 7x. Negative 2x. Now we're picking up that minus 3 Garrett was talking about. Drop it all the way down. And we start the process over. X squared times what gets you 18x squared.
18.
Just an 18 because it's already got the x squared. So I take this 18, distribute it to all 3 of those terms. So 18 times x squared is 18x squared. 18 times negative 3x, is that negative 54? 18 times 3, negative 54x. And then 18 times 1 is 18. Subtract 18x squared minus 18x squared is nothing. He gone. Negative 2x minus negative 54x. 52x. Negative 3 minus 18. Negative 21. There's nothing left to bring down, so that's your remainder. So to write your answer, we've got what we had on top, so this stuff up here, plus my remainder, which was 52x minus 21, over what I divided by. X squared minus 3x plus 1. So all of that is your answer.
What are we not finished on that?
It's on the back side of this sheet. Oh, the test. I thought you meant the one lesson I said we were hanging on. We'll worry about that if that happens. No, there is.
Just put what we divided by the x squared minus 3x plus 1 under 52x minus 21 or under it all?
Just under the 52x minus 21. Just under the remainder. Yeah, that is a lot. I agree. Alright, on number 9. Gives you those two graphs, f of x equals x to the fourth and g of x equals x plus 4, that whole quantity to the fourth. So part A says, oh, my bad, thank you, my bad, thank you. I missed 8, my bad. Number 8, I was getting excited. Number 8 has got 3x plus 1 cubed. Thank you, Mr. Cross. So, just like on number 3, that doesn't mean we just distribute the cube. That means we got to write the 3x plus 1 3 times. Very good, very good, very good. So, I'm going to go ahead and just work the first two. So, that's going to get me 9x squared. And Lane Joe, that shortcut will work here. 3x. 3x. And then 1 times 1. So when I combine those like terms in the middle, I've got 9x squared plus 6x plus 1. Now I need to bring down the other 3x plus 1 and multiply it.
Then you get 27x.
27x cubed. 18x squared. 3x. And now my 1's got to go to all of them, so 9x squared. 6x plus 1. So those like terms that we have there, it's us a 27x cubed, 18 and 9, 27x squared, 9x plus 1. Okay, so on 9, gives you the functions, the f of x and the g of x, gives you the equations. Part A is kind of tricky. It says how many zeros does each function have? Well, remember, zeros is where it crosses the x-axis, so a lot of people are going to look at those and say, well, they only touch the x-axis once. Not the case. Remember, we talked about when it turns somewhere, it probably stays there a little bit longer. And both of the powers on both of those functions are to the fourth power. So that's actually telling you how long it stays there. So using that information, how many zeros do you think they have? What's the power on the equations? What's the degree? 4. So even though it just is hitting that 1 0, it's staying there a long time. So they each have, f of x has one distinct 0. But when we solve that out, it would stay there. So if you get that answer more than one time, like we did when we worked these in class, that's called multiplicity. So it has 1 0 with a multiplicity of 4. Okay, so the same with g of x. It has 1 0 with a multiplicity of 4. And why 4? Because your highest power is 4. Okay, so if it had been a 3, you would say a multiplicity of 3. So they're both hitting the x-axis on that one spot, but it turns there, it stays there, they hit that, it's a multiplicity of 4. So those are your A answers. Okay, part B says describe the transformation. Well, you got this. This is easy. Describe the transformation. Look at your equations. Look at the graphs. To go from F to G, what does it do?
A horizontal translation of the 4 left.
4 left. Very good. And Lady Jo gave you all of the correct math terms there. A horizontal translation. Okay, now part C, when it's talking about increasing or decreasing, and it's on the G function, so don't worry about the F one. Look at the graph of G. Remember, when we increase and decrease, that's when I talk about riding my bike uphill or downhill.
It's decreasing.
So it starts off decreasing, and it does that on the left side of -4, right? And then you turn uphill and you start increasing on the right side of -4. So those are your C answers. Very good. Y'all are getting better at that. Alright, last one for today, number 10. Are you ready? Says the volume V in cubic feet of a hot tub is modeled by the polynomial there, where x is the length of the hot tub. So first thing it says, explain how you know x equals -5 is not a possible rational zero. And there are two ways to explain this. Number one is using common sense. I'm not going to have, if I'm actually talking about the volume of a hot tub here, volume of most things is length times width times height, so I'm not going to be able to have a dimension of a -5.
Because it's not going to be.
Right, I mean, this is going to be something measurable. So
I did the math and
so,
then realized that I
okay.
could use common
Well, now I am going to show you the way to do it with one way to do it with math. First off, you can plug -5 into the original equation. Okay. Other way that relates to this unit would be right here. So I'm going to plug the 0 they said, -5, a 1x cubed, a -10x squared, an 11x, and a 70. And I'm just going to show that I don't get a 0 in the remainder spot, because this is what you're going to have to do on part B also. So one of them's -5 is -5. I add and get -15. -15 times 5, is that 75?
Yes.
I add and get 86. 86 times -5. Somebody help me out on that.
-430.
-430. And I add and get -360. So to show that that's not a 0, -360 is not 0. Okay, if it worked, I would have gotten 0 in the remainder. 0 would have equaled 0. So that's what you show on your part A answer. Now for part B, it says show x plus 2 is a factor, and then factor completely. So I'm going to start with the same deal here. 1, -10, 11,
70.
and 70. So if x plus 2 is a factor, I'm dividing by my -2. So 24 plus 11 is 35. 35 times -2 is -70. So there showed that it is a factor. But then it told me to go on and factor it completely. So this started off as x cubed, which means now I've got an x squared.
Can you factor by grouping them?
And that does do what, sweetie?
Can you like factor, like get the
A times C here? Yes. This is real easy to factor here. The factors of 35 that add to negative 12 are negative 5 and negative 7. So then don't forget your first factor that they gave you was x plus 2. So there's your factor completely. Now, they were close when we tried negative 5, but it needed to have been positive 5, didn't it? Because x minus 5 equals 0 gets you a positive 5.
Wait,
Yes.
so to get 24, you have to times 12
Where's
and
20?
2?
I got, yes, negative 12 times negative 2 got us the 24.
So 24 and negative 2 got you 70.
No, 35 times
So the final
negative
answer
2.
you times by negative 2 to get the next one.
Yes,
Oh, okay.
yes, yes. All right, so hang on to that. Tomorrow we'll do the back page, and there's a couple things on the back page that we're going to skip, and then there's a couple of things that might be new on the back page. So we'll save that for tomorrow.